Okay, this is part 2 of integration by parts. The second problem I'm going to do for you is the integral of x squared e to the x dx. Again, I'm going to use the mnemonic, natural log, inverse trig, polynomial, exponential, and trig. And I have polynomial first of that order. So I'm going to let u be x squared, then du is 2x dx. And again, once this is chosen, the remainder is dv. So dv is e to the x dx. Taking the antiderivative of this gives me v is equal to e to the x. Once again, integration by parts is u times v minus the integral of v du, taking u and v from my work above, x squared e to the x minus the integral of v e to the x du 2x dx. Now, it appears I have the similar problem that I had before, so I'm going to apply integration by parts one more time. Again, choosing the polynomial x, du is dx, dv is e to the x dx. The antiderivative, again, is e to the x. I didn't deal with this 2, I'll just have that as a coefficient. So x squared e to the x minus 2 times, again, using u times v minus the integral of v du, u times v minus the integral of v du. This time it looks like we should be able to carry this out. I'm going to distribute the 2. I'm going to distribute it actually negative 2. So it's going to be plus 2. The antiderivative of e to the x dx is e to the x. And then finally plus c. There's my second example. One more example that I'd like to show you, and that is e to the x sine of x. This time, following the mnemonic LIPET, I choose u as e to the x. Then du is e to the x dx. dv is sine of x dx. The antiderivative is v is equal to opposite cosine of x. Again, remember I'm doing uv minus the integral of v du, u times v, opposite e to the x cosine of x, u times v, minus the integral of v, with this negative becomes positive, times e to the x dx. So similar to what I had before, I still have an issue here. Again, I let u be e to the x. See where that takes me. du is e to the x dx. dv is equal to cosine of x dx. So v is sine of x dx. Just bringing this term down, plus, now again, I've got u times v minus the integral of v and it seems like I've gone into a circle because recall this is all equal to this original expression, the integral of e to the x sine of x dx. And it seems like I'm not getting where, but in fact, that is what's going to help me to solve this integral. I'm going to add this to both sides of the equation. I have the opposite of e to the x cosine of x plus e to the x sine of x. And you can see that this is equal to that original integral, as I said. So I have 2 of the integral e to the x sine of x dx. if that's what 2 is equal to, then one of them would be 1/2 of the opposite of e to the x cosine of x plus 1/2 of e to the x sine of x. And don't forget, I need a plus c.